here. We are discussing analog electronics, and this is the next topic of analog electronics, BJTs. So BJTs are bipolar junction transistor. In BJTs, what you have to remember are there are three configuration: common emitter, common base, and common collector. You have to at least remember the values of the gains of current gain and voltage gains and the input and output resistance formulas of all the four type of configuration. The fourth configuration is basically common emitter and common emitter with bypassed and unbypassed emitter resistance. So these things you have to basically know if you are solving the questions related to BJTs. Otherwise it will be little difficult for you to solve the problems against BJTs. So let's just discuss how to solve the problems of BJTs. Okay, so this is our question. In this question it says that in the voltage regulated circuit shown below, VI here is equals to 15 volts. Assume VBE is equals to 0.7 and the base current is negligible for both of the BJTs. If the regulated output is equals to 9 volts, the value of R2 will be equal to what? You have to find out this value. Now what it is saying in the circuit that the value of VBE here is equals to 0.7 in both the cases. So this value, this is the base terminal, this is the collector, and this is the emitter. So this volume will be VBE. This is VBE 0.7 here also, and this is again base, collector, and emitter. So plus minus VBE will be equal to 0.7 volts. Now it is saying that output value is equals to 9 volts. We have to find out the value of R2. It is a very easy question. It looks difficult, but here you have to find out this value of R2. It is just simple a voltage divider rule. Now if I know this value V, suppose Vx, so if I apply the voltage divider rule, let's say what will be the voltage divider rule says I want to know the find out the value of voltage here. So Vx will be equal to R2 into total voltage. So total voltage here is nothing but 9 volts. 9 divided by R1 plus R2. Now here two unknowns are there, this value of Vx and this value R2. R2 we have to find, but Vx we can easily find from here. Now since it is a voltage regulator circuit, so voltage across this Zener diode given to us is what? It is equals to 3.3 volts. Now if I apply KVL here, so starting from here 3.3 volts plus 0.7 volts minus Vx is equals to 0, right? So Vx here will be equal to nothing but 4 volts. So if I replace here, 4 is equals to R2 into 9 divided by R1 value we know it is equals to 1K plus R2. From here if we find out the value of R2, it will come out to be 80 ohms. So 80 ohms will be the right answer for this. R2 will, sorry, 800. It will come out to be 800 ohms. So if you solve this all, it will be because this is 1 kilo ohms, right? So you can write this as 1000. Right, so if you solve this all, so this complete big circuit is basically not useful in this particular set of question. Sometimes they give you a huge circuit, but you can find out the solution from the smaller part of that particular circuit, right? Because the solution was just hiding behind this particular area only, right? So you have to just apply your brain that how to crack that particular question. Okay, next question says that for the BJT in the amplifier shown below, right? This is a proper coupled amplifier given to us. Okay, VB is 0.7 kT by Q, that is the thermal voltage given to us is equals to 26 millivolts. Assume that BJT output resistance R0 is very high and the base current is negligible. So they are saying that the output resistance R0, it is assumed to be infinite and base current IB is assumed to be 0, almost equal, negligible, that means it is almost equal to 0. The capacitor are also assumed to be short circuited at the signal frequency. If the input is directly coupled, the low frequency V0, so they are asking us to find out the gain. Now this is so you have to first analyze that which type of amplifier this is given to us. It is not given, right? They have just written the amplifier, they haven't given us the configuration, whether it is a common emitter, common base, or common collector. You have to just check that from where we are collecting giving the input, and from where we are collecting the output. That will give up the configuration. So input is given to the base, this is the input, and output we are collecting from the collector. So this is common emitter. So common part is common emitter configuration is this. Common basically means if I am saying that something is common, that means I am grounding that particular terminal. So all the capacitances will be short circuited. So this will be short circuit, this will be short circuit. So RE in parallel with this will be also short circuited. All the DC supplies will be grounded when we are doing the AC analysis. So this will be grounded. So that means this is connected to 0 volts. That means emitter terminal is on ground. That means what? Common emitter configuration. We can easily recognize what type of configuration is given to us. So this is common emitter configuration given to us. Now if I redraw this particular circuit, so input is given here, and this is RC, and we are collecting output from here, and there is also load resistance connected to the output. So this is equals to 10 kilo ohms, and this is just connected to ground. Now they are asking us to find out the gain, right? Gain, which is voltage gain. So you have to remember the formula of voltage gain in this. This is what? This emitter resistance is bypassed. This is bypassed RE case. So in this case, gain, the voltage gain is equals to, you have to remember these formulas at least by heart. So voltage gain will be equal to minus GM RL parallel with RC. So this is the value of voltage gain. So now in this case, load resistance is given to you, RC value is also given to you. You have to find out the value of GM, that is equals to transconductance. What is the value of transconductance? Transconductance GM is equals to IC by VT. This is the value of, this is how you can find out the value of transconductance GM. Now GM is equals to IC by VT. VT value is given to us, that is equals to 26 millivolt. We have to find out the value of collector current in this particular case. That's why I have drawn this circuit. Now how you will be finding out the value of the collector current? Now this value I need, IC value I need, right? So from this, if I am, this is the AC analysis I have drawn. In order to find out the value of the collector current, I have to draw the DC, right? Now if I draw the DC, so this is equals to 10 volts, and in this case RE will be there. If I am drawing the DC, so that will be 20 kilo ohms will be there, because in DC analysis capacitors will be open circuited. So this will be also open circuited rather than short circuit. So here it is given to 10 and this is given to ground. In DC, AC will be open circuit, the capacitors will be open circuit. So this is the circuital change we have to do when we are doing the DC analysis, sorry. Right, now you have to find out this current IC. Right, there are 2 or 3 ways in order to find out the IC. First ways we have to always find out this IB current. IB, if we find out the value of IB, IC is always equals to beta IB. But there is no such information of beta, that is the current gain given to us. Now in this particular case, the information given to us is that IB is equals to 0. So we can say that if IB is equals to 0, then IE, which is equals to IC plus IB, that means IE, I can write that this is nothing but IC current only. So this is IC similar, This is although emitter current, but this is same as IC current. Now I can easily find out IC. IC will be equal to what? Same current is flowing, right? Same current is flowing inside it. So I can easily say that IC current will be equal to, from voltage it is 10, right? So I can draw a loop here, loop, because this is grounded and this is supply given to us. So from this, if you find out the IC current, that will be equal to 10 minus, this is what? VBE, 0.7 volts. 0.7 volts divided by the value of resistance. Resistance is 20 kilo. Right? Easy or not? If you want to see the correct, I have just directly given the I have directly written the value of IC. If you want to know the correct complete equation, so we will start from 0 volts. 0 volts minus, this is what? 0.7 minus, in this we will encounter this resistance value. So in this resistance value, what current is flowing? IC current or IE current, or anything you can write. Both are both are same, right? 20k into IC, right? Plus this is negative of 10, right? That's why plus 10 volts is equals to 0. From this equation, I can easily find out the value of IC. So IC value come out to be, I have the direct result, so it come out to be 0.465 milliampere. So IC value will come out to be like this. So from this, if I put the value of IC in here, I can easily find out the value of GM. So 0.465 divided by the VT, 26. Right, both are milli, both will cancel out, because this is also volt and this is also milliampere. Now if I know the value of GM, I can put everything into the formula. Right, I am erasing this DC analysis. So gain V0 by Vi is equals to minus of GM, 0.465 divided by 26 into RL parallel with RC. RL parallel with RC will be 10 into 10 divided by 10 plus 10. Anyway, both resistance are same, so parallel case, in the parallel case, resistance will become half. So if you solve this completely, we will get the value of gain to be minus 89.4. Minus 89.4 will be the value of the gain. Right? This is if you are finding out the parameters, suppose GM or R pi, beta, anything like that. If we are finding out alpha, any parameters of this BJT, then we have to do the DC analysis, right? Then we have to do the DC analysis. In DC analysis, what we do is we replaces all the AC supplies to be open circuit, and also all the capacitance are assumed to be open circuit as well. So in that case, we can easily do the DC analysis by taking this VB. Or you can say in the 99% of the question, you have to apply a loop here in order to find out this current IB, and second loop will go here, start from here, IC current, and this VC will come, and this VC sometime they give, sometime they don't give, sometime they'll ask this VC value only. So second loop will come across this. So only two loops you have to remember if you are solving any question regarding this amplifier configurations. Right, so from this loop you always get the value of IB current, because mostly you know that VB is equals to 0.7 volts, right? And in second loop you can get information regarding to the IC current, or you can get the information of VC, something like that. So these all things, if we are finding out the voltages, currents, or parameters of the BJT, that we have to do the DC analysis. And if they are asking us to find out the gains, then you have to move into the AC analysis, because what they are asking is gains in terms of frequencies. So you have to remember these formulas, right? When you are doing the AC analysis, what will be the value of gain? So they are asking us the voltage gain. What will be the value of voltage gain? What will be the value of current gain? What will be the value of input and output resistances of these configurations, right? Only then you will be able to proceed with the BJT questions. Otherwise it will be very impossible, because if you don't know the formula of gain, there is no time in the exam or interview or any kind of paper you are giving. So there is no such time that you solve it completely, draw the equivalent BJT model and just to find out the value of the gains, right? So just remember them by heart. Okay, moving on to the next question. Next question says that in the circuit shown, transistor Q1 and Q2 are biased at collector current is equals to 2.6 milliampere. So collector current is given to us, which is equals to 2.6 milliampere. Assuming that the transistor current gain are sufficient large to assume collector current equal to emitter current. In this case also beta is given very large. So this gain, that means beta value is given very large. So if beta is large, our assumption is that base current will become equal to 0. That means IC is equals to IE. This is what they have written also. Right, and the thermal voltage is 26 millivolts. The magnitude of the voltage gain V0 by Vs. So input here is this, and this is the output. In the midband frequency range will be equal to what? So again we have to find out that what is the configuration of the this particular. So here Q1 and Q2 is given. So input is given to this particular amplifier, and output also we are taking from this particular amplifier, which is equals to Q1, and this will act as nothing but load. This complete is acting as load to emitter terminal. Right, this complete circuit, the Q2 will be acting like as a load to this emitter terminal. Now we have to replace this circuit in DC analysis in order to see that how this particular load is acting, right? If I redraw this particular into its equivalent DC, so what we will have? So this is this circuit here. If I remove all the DC supplies, sorry, AC, I have to check whether this particular circuit is acting like which type of load it is acting like, right? So this is my Q2 and this will be grounded. Again, this is what? In AC, capacitor will be short circuit. So short circuit and short circuit in parallel with the resistance will be also short circuit. So this is also ground. So this is grounded. Both base and emitter terminal is grounded. So this particular arrangement of this transistor is basically what? If I am grounding both base and emitter, it is acting just like nothing but a diode, right? This will act like nothing but diode, and diode in AC analysis will replace with the dynamic resistance. So in this case of transistor, because it is not actually a diode, so in this case of transistor, this dynamic resistance will be equal to 1 by Gm, 1 by transconductance only. Sorry, 1 by transconductance only. So this is how the Q2 will be acting. It is acting just like a load to what? Emitter terminal of Q1, because the main transistor is this Q1 only, because we are giving input to the Q1 and taking output from the Q1 and only, right? And Q2 is acting like load, right? So this will be the value. This is how we will be replacing this transistor. So if I redraw the circuit, this is output, this is Q1, and here it is a transconductance 1 by GM, isn't it? This is also grounded, right? This is P naught and this is Vs, this is V naught. Now they're asking us to find out again. V naught by Vs is voltage gain. Now what configuration you can see here? What is this? This is here input is given to base and output we are taking from collector. Again, this is nothing but a CE amplifier. Common emitter amplifier configuration is given. Now in this case, the RE is not bypassed, right? RE is not bypassed. So in this case, unbypassed RE is there. So for unbypassed RE case, the gain will become equal to minus GM RL divided by 1 plus GM RE. Okay. Sorry, RE. Right, this is the voltage gain in case of common emitter amplifier when the situation is given to us, which is equals to unbypassed unbypassed emitter resistance, right? So this will be the gain. Now in this case, RL is given to us, RE is also known. Now in this case, we have to find out the value of GM. So how we can find out the value of GM? Again, it is same. GM is equals to IC by VT value we know, we have to find out the value of IC. IC is given to us, in fact. IC is given to us, which is equals to 2.6 milliampere. So both everything is given 2.6 milliampere divided by 26 millivolts. So it is equals to what? Now it can cancel out. So IC will be equal to 0.1. So GM will be equal to 0.1. So GM value we know. Now after finding out the value of GM, we have to just find out the values of gain. Minus 0.1. RL value we know, which is equals to 1 kilo. So this will become load. RC will become load resistance here, because this is the common point, and we can just, if you want to shift it to see that whether it looks like load or not, right? So this will looks like load here, because above it was grounded, because above it is connected to 5 volts of DC supply. In AC analysis, we just short circuit the DC supply. 1K divided by 1 plus GM RE will be equal to what? GM value is equals to 0.1 and RE will be equal to what? 1 by 0.1. So if you solve it completely, the gain will become equals to, it will come equal to minus of 50 volts. They are asking you to find out the magnitude. So for magnitude, V0 by Vs, the gain will be equal to just 50. The gains of common emitter will always come negative, because common emitter will give you a 180-degree phase shifted wave output. So that's why the gains are always negative for common emitter configuration, right? It was an easy question again. They're asking you to find out the gain, and the gain formula you have to remember. After remembering the gain formula, you have to find out the value of GM, right? GM, everything is given in order to find out the value of GM. So put everything into the formula and find out the value of gain. Okay, moving on to the next question. Next question says that consider the circuit shown in the figure. Assume base to emitter voltage VBE is equals to 0.8 and the common emitter base current is equals to alpha of the transistor is unity. Right, alpha here is equals to unity. What is the value of alpha? Alpha is IC by IE. If it is equals to 1, that means IC is equals to IE again, right? That means, that implements the base current is equals to 0, right? What they are asking you to find out the value of the collector to emitter voltage. So this is what they are asking. right? This is a this is a biased transistor, just a DC biasing is done. Now in this case they are asking you to find out VCE, right? This is voltage biased transistor, right? So in this case what we take is, this is R1 and this is R2. We take the Thevenin equivalent of that particular circuit. So Thevenin equivalent of this particular circuit will become like this. So this is VTH, RTH, voltage divided by circuit. This is known as, I was just remembering the name. This is voltage divider biased circuit. There are, in theory, we read three types of biasing of BJTs. So this is the mostly or widely used type, because we do biasing because we have to keep the BJT working into its active mode. That's why we do biasing mainly, and to keep the uh, uh, Q point in the middle of the load line. There are the two main reasons, right? So this is 18 volt. Now how we can find out the VTH? VTH will come across this particular resistance. Just by voltage divider rule we can find out the value of VTH. VTH will be equal to 16 into 18 into 16, 18 into 16 divided by 16 plus 44. That will be the VTH, and RTH is equals to 44 in parallel with 16. So this is how we can find out the value of VTH and RTH. The values of VTH and RTH, VTH will be equal to what? 4.8 volts, and RTH will be equal to, let me calculate the value of RTH. So both are in parallel. So 11.7. Both are in kilo, right? So 11.7 kilo ohms will be the value of RTH, right? Now what they are saying is you have to find out the collector emitter. Now why I have converted into this configuration? Because in this configuration it is easier now to solve for VBE, because here the current here will go like this, right? I cannot apply a loop like this because current at this point is distributed at two particular nodes, two particular sides, right? That's why I have converted this particular circuit into its Thevenin equivalent. This is the Thevenin equivalent circuit of voltage divided by circuit. Now I can easily apply a loop here, and then they are asking us to find out VCE. For second, after applying the second loop, we can easily find out the VCE value. From the first loop, what we will get? We will get the value of this IC current. Now let's just apply KVL in loop 1. So VTH, now current here is IB is equals to 0. So I'm just putting VTH minus VTH, we know it is equals to 4.8 volts minus 0 minus this VBE is 0.7 minus 0.7 minus IC into 2K, which will be equal to 0. Now from here I can easily find out IC, or you can say this is IE current, both are same. IC is equals to IE, and the value of this will be equal to 2 milliampere. 0.8 given. VB is given as 0.8. Sorry, my mistake. Right. So IC will come equal to IC will be equal to IE, which will be equal to 2 milliampere. Now I can easily find out the value of VC if I apply KVL in loop 2. I'll start from here. 18 minus 4K into 2 milli minus VCE minus 2K into 2 milliampere, and it will be equal to 0. Only one variable is here in this particular equation, that is nothing but VC. So VC will come out to 6 volts. We can easily apply KVL in these two loops in order to find out the value of VC. That is a very easy question, right? So we can find out the value of VC like this. Right, two loops. I have told you in the previous question as well. What we have in basically in order to solve the DC analysis of BJT circuits, we have to go through two loops. Right, this is the first loop and this is the second loop. By using these two loops, we can find every voltage and every current in this BJT circuit. Right. Moving on to the next question. Next question says that in the figure shown, the NPN transistor act as a switch. Right, this particular circuit act as a switch. For the input V in as shown in the figure, the transistor switches between cutoff and saturation region of the operation. So transistor will switch between cutoff and saturation region, right, for this particular input, right. For this particular range, because input is there, so it will act in saturation, and this is cutoff, there is no input, right. When T is large, assume that the collector to emitter voltage VCE saturation is equals to 0.2 volts. So this VCE is given as 0.2 volts, and the base to emitter voltage is also given as 0.7 volts. 0.7 volts. For the minimum value of the common find the minimum value of the common base current gain, we have to find out the alpha for the transistor for the switching should be. What you have to find out the minimum value of the alpha. Now in this particular circuit, what is happening, this supply is given and the circuit is switching itself from saturation to the cutoff region. So what they are asking is the value of alpha minimum will be equal to what? So how we can find out the value of alpha minimum? By applying same. If I go through the first loop, right, so V in, which is equals to 2 volts, right, for the positive half, 2 volts minus 12K IB minus 0.7 volts will be equal to 0. That will be the equation of the first loop, right. In this case, I can easily find out the value of IB. So IB value will come out to be 1 milliampere. Now, in order to keep this into saturation, what IB should be greater than equal to IB minimum. IB minimum is the value in order to keep or make this BJT or BJT into its saturation mode. So IB value, the base current which we calculated, should be greater than equal to IB minimum. IB minimum is equals to IC saturation by beta. This is the value of IB minimum that should be greater than IC saturation by beta. So from this, I can say that IB should be greater than IC saturation, that is equals to saturation current is given, right, 1 milliampere divided by beta. So beta value should be greater than equal to 1 by sorry, this IB value it's incorrect. The correct IB value is, if we solve this, the IB value will come out to be 0.1, 0.108, sorry, milliampere. Should be, it should, the statement was correct. IB should be greater than equal to IB minimum, and IB minimum which is equals to IC saturation by beta. Now we have to find out IC saturation also. IC saturations, because I know VC sat, it is like this. So IC saturation we can easily find out. This is the IC current, right? So this will be 5 minus 0.2 divided by 4.8 kilo. So it will come out to be 1 milliampere. Now putting everything, so we can say that beta will be equal to what? IC saturation is came out to be 1 milliampere divided by 0.108. So beta value will come out to be, the final value of beta is 9.23. 9.23 is the beta value. Beta minimum. Now we should know the relation between alpha beta. So alpha minimum will be equal to beta minimum divided by 1 plus beta minimum. So 9.23 divided by 1 plus 9.23. So it will come out to be 0.902. Now in this case, only one condition you should be knowing, that this particular circuit, this particular BJT, it is given into its saturation mode. So if it is in saturation mode, then minimum current will be flowing inside the base, right? Minimum current will be flowing inside the base, and the current flowing inside the collector region will be known as IC saturation. So the formula of minimum base current is equals to IC sat by beta, right? We can easily find out the values of IB and IC from the given parameters in the questions. We have easily find out the value of IC sat and beta by applying this KVL in loop 1, and this is for KVL in loop 2. Right, after finding out the values of the currents, we can find out the value of beta, and that beta will be minimum beta, right? Minimum beta. And now we know the relation between alpha and beta. So alpha is equals to beta minimum, beta divided by 1 plus beta, right? So if we have minimum beta, that means alpha will also be minimum. So minimum alpha will be equal to 9.23 divided by 1 plus 9.33. So it will come out to be 0.9 over 2. Okay. Moving on to the next question. Okay, for the DC analysis of the common emitter amplifier, now in this particular question, the configuration is given to us. So common emitter amplifier is given to us. Neglect the base current and assume the emitter and the collector currents are equal. So both, again the same thing. So IB we have considered will be equal to 0, given that the VT is equals to 25 millivolts, VB is equals to 0.7 volts. The BJT output resistance R0 is practically infinite. So R0 is also equals to infinite. R0 is also an internal parameter of BJT. It's mostly infinite in most of the cases. Under these conditions, the midband voltage gain. So again, you have to find out the voltage gain. In this particular question, you have to find out again the voltage gain V0 by Vi, the magnitude basically you have to find out. Now the configuration is given to us. Configuration is given to us is it is equals to what? Common emitter. So common emitter gain is equals to minus GM RL dash. All the load resistance, which RL dash is basically what? In the first question we also have, so all the load resistances in parallel. All load in parallel. Here we can see this and RC, mostly RL and RC. So RL parallel with RC. So our gain will be equal to minus GM RL parallel with RC, right? Because we can see easily here it is a bypass case. Bypass RE case. So for bypass RE case, voltage gain is equals to minus GM RL dash. Very easy to remember. Now what we have to find out is GM again. In order to find out GM, we have to do the DC analysis for this particular circuit. So if I convert this into its equivalent DC, so this is 12 volt, this is grounded, this is 2K, this is again 2K, this is 73K, this is 47K. This is again voltage divider configuration. We have to, what is GM? Why we are doing the DC analysis? Because we know the value of GM is equals to IC by VT. So in order to find out this IC, I have to do the DC analysis, because otherwise I won't be able to find out the value of IC, because nowhere in the question given the value of IC. That is what we have to calculate. Again, we have to find out this Thevenin equivalents. So this is 2K, this is 2K, this is VTH, this is RTH, 12 volts. So IB again is 0. So there's no need to calculate the RTH value. So VTH we can calculate by voltage divider rule. So 12 into 47 divided by 47 plus 73. So if we calculate it, the value of VTH will come out to be 4.7 volts. So 4.7 is VTH. Now again I have to find out the value of IC. So this IC here is also same IC. So only in one loop I can easily find out the value of IC, applying the KVL in loop. So VTH, which is equals to 4.7 minus 0 minus 0.7 VBE is given to us, minus 0.7, this value VBE minus IC into 2K is equals to 0. From there, from this equation only one variable is unknown. So IC value will come out to be 2 milliampere. Now 2 milliampere. Now I know the value of GM. So it is 2 milliampere. VT is given to us, which is equals to 25 millivolts. So GM value will come out to be what? GM value will come out to be 80. 25, 80. Right? GM is transconductance, so basically it will be what? In the unit will be in Siemens. Right? Now after finding out the value of GM, everything is known to us. Right? We have to just put the value of GM into the voltage gain formula and find out the value of voltage gain. If I remove it, the voltage gain will be equal to what? Minus 80 into RL is equals to what? 8K in parallel with 2K. This is bypassed, right? So this is bypass. So voltage gain will come out to be 1 minus 120A. What they're asking is magnitude. So magnitude will become equal to what? 128. So this way we can easily find out the voltage gain. That was the easy question again. Right? We have to find out, in this case there is no need to find out the configuration as well, because they have directly given us the configuration. This is equals to common emitter, right? If the common emitter is directly given to us, then we should know that if it is bypassed or not bypassed. So because we have two different formulas for bypassed and not bypassed, right? This we know that this is a bypass case, bypass RE case. So in this case, bypass RE case, the gain is very easy to remember, minus GM RL. So RL is everything which comes into the load. So this and this will come into the load, because when we are doing the AC, this will be also grounded. and this is anyway grounded. So both will come parallel to each other, right? This will also come parallel to this, right? So both will be in parallel, and if R naught is also there, if they give us the value of the R naught, then it will also come into the parallel, right? But they have given that it is practically infinite, so we'll just assume that to be open circuit. Okay, moving on.